In a seismic shift, America's once unrivaled GPS dominance is slipping away to China's BeiDou system. What does this mean for global navigation and security? Stay tuned to find out more. The United States and China have been competitors across a range of fields, spanning from athletics and the Olympic Games to manufacturing and the pursuit of global dominance. Presently, their rivalry has shifted to a smaller yet significantly crucial battleground, the domain of microchips and semiconductor technology. This sector is fundamental for the progress of contemporary technologies and has emerged as the latest focal point of their ongoing strategic rivalry. The semiconductor sector occupies a vital position in our society, influencing the structure of our daily routines, the economy, and the trajectory of technological development. Semiconductors, also known as microchips, serve as the unseen intelligence within almost all modern electronic devices that we depend on daily. From the instant you glance at your smartphone in the morning, possibly containing as many as 100 distinct chips, to the vehicle you drive, now equipped with sophisticated driver assistance systems reliant on semiconductors for safer and more effective operation, these minute components are indispensable. Moreover, semiconductors lie at the core of technological advancements. They are indispensable for pioneering innovations like artificial intelligence, which is revolutionizing sectors ranging from healthcare to entertainment, electric vehicles that are charting a course toward a more sustainable future, and renewable energy systems that pledge cleaner energy alternatives. China, as one of the founding members of the BRICS alliance, stands as the globe's primary marketplace for semiconductors, commanding 31.4% of total worldwide sales, equivalent to $180 billion out of a $574 billion global market in 2022. China spearheads the expansion of the semiconductor industry, with projections indicating its chip manufacturers will initiate 18 new projects in 2024. This surge is fueled by governmental backing and incentives, with the aim of achieving a staggering 133% year-on-year growth in capacity, reaching 8.6 million wafers per month by 2024. China is swiftly enhancing its semiconductor manufacturing capabilities, striving for autonomy, and eyeing to produce a quarter of the world's semiconductors by 2030. Among the myriad of enterprises, Huawei plays an active role in semiconductor chip production, utilizing its HiSilicon subsidiary to design chips manufactured by the Chinese company SMIC. China has positioned Huawei and SMIC as frontrunners in its drive for semiconductor self-sufficiency, enabling Huawei to wield considerable influence over semiconductor policymaking within the nation. This strategic maneuver is part of China's broader endeavor to advance its semiconductor manufacturing capabilities, despite U.S. export controls aimed at curbing access to cutting-edge technology due to apprehensions regarding China. In contrast, the United States has enacted the CHIPS and Science Act of 2022, offering substantial support to elevate domestic semiconductor manufacturing and research and development, or R&D efforts. Additionally, stricter export regulations targeting China have been enforced to safeguard technological advancements. The CHIPS Act, now enacted, allocates $52.7 billion in federal subsidies to fortify the U.S. semiconductor industry, addressing disruptions in the supply chain and bolstering competitiveness. It emphasizes the establishment of semiconductor fabrication plants, with allocated funds also dedicated to supporting research, development, and workforce training. Nevertheless, beneficiaries are subject to constraints preventing the expansion of manufacturing in China or nations perceived as security risks to the U.S. The narrative continues beyond this point. In May, Japan escalated restrictions on the export of 23 categories of semiconductor manufacturing equipment, surpassing the initial constraints set by the United States. While the U.S. focused on limiting the export of tools essential for producing cutting-edge chips, particularly those at the 14-nanometer generation or smaller, Japan expanded its restrictions to cover equipment used in manufacturing older, less advanced chip generations down to the 45-nanometer level. This broader scope has sparked concerns within the Chinese semiconductor industry regarding potential disruptions in the production of essential chips used in everyday products, including automobiles. By the conclusion of June, the Netherlands also tightened its export controls, imposing restrictions on the shipment of deep ultraviolet lithography machines to China. These machines are vital for chip patterning. This action represented a significant expansion beyond prior regulations, which since 2019 had only limited the export of the most advanced extreme ultraviolet lithography machines. In reaction to the U.S. CHIPS Act, China has heightened its commitment to semiconductor self-reliance and technological sovereignty, recognizing no alternative but to transition from a market-driven to a security-driven national innovation system. This strategic adjustment underscores the importance of addressing technological bottlenecks and mastering core technologies as a primary objective. However, previous initiatives akin to this approach have resulted in economic distortions and inefficiencies, prompting concerns about the sustainability and effectiveness of such a strategy. As reported by Citigroup, the strategy pursued by the U.S. could inadvertently bolster Beijing's resolve to achieve technological self-sufficiency, potentially leading to unintended consequences for its own integrated circuit companies. Meanwhile, India is actively striving to enhance its standing in the global semiconductor manufacturing race through the establishment of its inaugural semiconductor fabrication plant. This initiative was announced by the Israel-based International Semiconductor Consortium and is backed by a $19.5 billion investment from Indian conglomerate Vedanta and Taiwanese manufacturer Foxconn. Situated in Gujarat, India's semiconductor and display production facilities aspire to play a pivotal role in the semiconductor industry. Projections indicate that the country's semiconductor consumption will surpass $80 billion by 2026. Despite these ambitious endeavors, India may encounter obstacles such as bureaucratic inefficiencies, as well as challenges related to water and energy supply, which could impede its ability to compete effectively on the international stage. In the Middle East, Oman, alongside the United Arab Emirates and Saudi Arabia, is making notable progress in entering the semiconductor industry. The World Semiconductor and Chip Summit hosted in Oman aims to attract investment in this sector. These nations are leveraging their existing technological investments to contribute value to the semiconductor industry, with the goal of diversifying their economies and reducing reliance on oil. However, the entire region faces challenges stemming from the global chip shortage and production declines resulting from geopolitical tensions. Expanding the scope beyond these regions, the semiconductor industry as a whole is poised for a robust recovery in 2024, with anticipated global sales growth of 13% to $588 billion. This resurgence is primarily driven by the rebound of the memory chip market, alongside increased sales of PCs and smartphones, which represent critical end markets for semiconductors. Intel Corporation, Samsung Electronics Company, RlD, Qualcomm Incorporated, Micron Technology, Incorporated, and SK Hynix Incorporated stand as key players contributing to the partially consolidated structure of the semiconductor industry. These entities are employing tactics such as partnerships and acquisitions to enrich their product portfolios and solidify competitive advantages. IDC projects a promising trajectory, foreseeing an annual growth rate of 20% for the semiconductor market in 2024. This upsurge is attributed to escalating global demand for artificial intelligence and high-performance computing, coupled with stabilized demand for smartphones, personal computers, infrastructure, and expansion in the automotive sector. The semiconductor industry serves as a cornerstone of the 21st century, fueling crucial technologies across diverse sectors like machinery, automobiles, and communications. Its pivotal position intensifies competition, with leading nations wielding significant influence over global technological and economic landscapes. This raises an intriguing question about the potential impact of the Global South in this fiercely competitive domain. The ongoing rivalry in semiconductor technology could profoundly shape the future of the digital and virtual realm, underscoring its critical significance. Unlike previous competitions, the outcome of this battle appears less predictable, with profound implications for global dominance in this pivotal 21st century sector. As technology evolves, the world closely observes to discern which nation will emerge as the predominant force in the semiconductor industry. What do you think will be the impact of emerging semiconductor players from the Global South on the dynamics of the semiconductor industry in the coming years? Feel free to share your thoughts and perspectives in the comments section below. Don't forget to become a part of the Revel Discovery community by hitting that subscribe button to stay informed about the latest technological advancements and innovations. Explore endless tech possibilities for an exciting future.